In this video, we're talking about two-step equations. For two-step equations, we still have to use the inverse operation, except we're actually using two inverse operations. Just a refresher, inverse operation is a pair of operations that undo each other. So for when you have addition, you'll use subtraction for the inverse, or the reverse, subtraction, you'll use addition. And for multiplication, you'll use division, or for division, you'll use multiplication. The objective is still the same for two-step equations, and that is to get the variable by itself. So let's take a look at an example. Here we have 2x plus 1 equals 7. I'm using the post-its again to represent my variable x. I have plus 1 set up on the board and 7 counters on the right-hand side of the board. Now, unlike our previous order of operations when you're solving for an equation, a numerical equation, for algebraic equation, our order of operation actually changes a bit. Before we had PEMDAS, so parentheses, exponents, multiplication, division, left to right, addition, subtraction, left to right. For algebraic equations, we're actually going to use SADMAP. So subtraction, addition first, going left to right. Division, multiplication, going left to right. Exponents, and then parentheses. So let's take a look at how this works for our example. The very first thing we need to do is actually subtract 1 from the left-hand side. So I'm going to use a zero pair here. So since I added a negative 1 to the left-hand side, I'll represent that up here, minus 1, I have to actually add a negative 1 to the right-hand side as well. Of course, this is a zero pair, so they cancel out. Here we have a zero pair as well, and they cancel out. So I'm left with 2x equals 6. At this step, we simply go ahead and group our counters with the variables. So we have 2 x's, and I want to evenly distribute my counters with each of the x's. So there's 1, each gets 1, 2, and 3, and then I'm out of counters. So the solution for this will be x equals 3. Up here, numerically, we're going to divide both sides by 2. The 2's cancel out. X equals 6 divided by 2, which is 3. Taking a look at a second example, we'll start with the algebra tiles this time and fill in our numbers. So on the left-hand side, we're starting off with 2, 4, 6, 8, 10 counters. And since they're red, they're going to be negative. And on the right-hand side, 2 positive counters and 3 variables. This is going to represent, we'll use y as our variable, 3y. Now, like the last time, I want to get my variables by themselves first. So I need to subtract 2 from both sides. I'll go ahead and use the counters for zero pairs. Since these are zero pairs now, I can take them off. I added 2 additional counters on this side, 2 negative counters, subtracted 2 negative counters. That's going to give me 3y left on the right-hand side of my equation and negative 12 on the left-hand side. So that's step 1. Step 2, now I need to organize the counters on the left-hand side so they're evenly distributed with my variables on the right. So there's 1, 2, 3, 4, 5, 6. So the solution for this equation will be y equals 4. Doing that just with the numbers, I'm going to divide both sides by 3. Be left with y over here because the 3's cancel out. and negative 12 divided by 3 is negative 4.